Dear business partners and friends of SWARCO, dear colleagues, good morning, good afternoon, good evening to all the places from where you are joining us today. I cordially welcome you live from the SWARCO Traffic World at our headquarters in Buttens in Austria. My name is Richard Neumann. I'm the head of communication and marketing of the SWARCO Group, and it is my pleasure to guide you through the webinar in the next 30 minutes. Thank you for joining our second innovation talk in a series of webinars we are going to offer you over the next months. The main purpose is to keep you posted about latest innovations by SWARCO in times where we cannot meet at exhibitions, conferences, and trade shows. The Innovation Talk allows you to get in direct touch with us via the chat function in the right-hand part of your screen. Please feel free to send us your questions or comments over the next few minutes. Following the interview, we will answer your questions in a Q&A session. Today's topic is about modern intersection control. The title of our innovation talk is SWARCO X-Line, the intelligent platform for energy-efficient intersections. I'm happy to welcome for this subject an expert from our system integrator SWARCO Traffic Systems in Germany, Mr. Matthias Nolle. He looks back to almost 20 years of experience in our industry. Matthias Nolle joined SWARCO in 2001 and is a specialist for urban traffic control for signalized intersections. After studying computer science at the universities in Karlsruhe and in Edinburgh in Scotland, he started in the development of our Actros controller line. Since 2013, he is the product manager responsible for the development of traffic controllers at SWARCO in Germany. Good morning, Matthias.
Good morning, Richard.
Thanks for being with us today here at our permanent showroom, the SWARCO Traffic World. Matthias, I remember that in the year 2000, SWARCO launched the first traffic light with a central light source. So the global conversion process to LED traffic lights has been lasting already for 20 years now. We all know about the advantages of LED technology in terms of brightness, power consumption, and reliability. However, the advent of the LED signals has also caused some challenges for the traffic controllers at the intersections. Can you explain to us what the actual challenge is or was?
First of all, thank you for the invitation. We have seen in the past that we have been able to reduce with the transition to LEDs the power consumption of the signals considerably. So we started off with incandescent lamps and those with 75 watts, and now we are down to, say, 5 to 9 watts per signal. And with the ever-increasing efficiency of the LEDs, we are now able to go down to a range of, say, about 1 watt, that we are able to drive a signal and get the light out of this one LED with only this little power. But then, let's recall that the most important thing for such an intersection is that we should be able to guarantee the safety. And that means at all times we have to know whether the light is on or off, and we have to supervise it. And then imagine if you have a distance of, say, 200, 300 meters, where you have to safely say whether the light is on and off. That gets more and more difficult if you have only such a low power. So what we wanted to make sure is that we have a path for the future, that we are able to cope with this situation, that the efficiency of the LEDs is going up and the power is going down, and we need to safely supervise our intersections.
So I see. What kind of solution has SWARCO found to tackle this challenge then? I heard it has to do with distributed intelligence. What does that exactly mean?
The idea that we had is currently we need to have a supervision of the lamps or of the LEDs, and that is hosted in the central cabinet, far away from the light. And what we did is that we moved this intelligence to supervise the light into the LED signal itself. This way we are able to very easily determine whether the light is on and off. But we had to change, obviously, the technology. It's no longer a switch that is going across the complete intersection, but it is a serial communication link that just sends a command to the light telling it to go on and off.
Mm-hmm. All right, so the title of our webinar is called SWARCO X-Line. What are the components of a modern intersection design according to SWARCO X-Line, and why is it called X-Line?
Well, first of all, obviously we have the signal. And the signal has the new intelligent component inside that is used to drive the signal and generate the light and supervise it. Then towards the signal we have now a 24-volt DC current voltage to actually make sure that the power is always available for the signal. The DC power has advantages because we are generating more stability within the complete system. And the CAN bus is a technology that we took from the automotive industry, and it is working very, very reliably, allowing to send commands towards any kind of embedded components, such as a signal, to actually drive it and supervise it. Mm-hmm. Then we have a component that is new, that is in the pole, that is headed as a central communication link in the pole that routes the traffic from the central cabinet towards the signals, and is also serving as a communication hub for the future, where we can additionally put other components like loops or like blind people signals. In the whole area of the intersection, we are using 48 volts DC and also a CAN bus. And this is a technology that we have been using for some years now, because we have it from a previous generation, and we have made very, very good experiences with this, so we can cross distances of up to 1,000 meters, which allows to build like applications and use intersections at cases where it wasn't possible before.
What are the advantages when you have a look at the traffic controller cabinet itself? What are the advantages of X-Line in this respect?
You have to imagine that in old times it was needed that you had to have a switch and a supervision unit for each and every light signal. Nowadays this is no longer needed. That saves a lot of space. So we are able to build cabinets that are much, much smaller and have these on really big systems. That is one advantage, and the other one is more headed towards the future. What we are having in the cabinet is we have a power supply that is the same as you could use for a house. And now, with this new and energy efficient technology, it is possible to actually run the complete intersection with a power consumption like 200 watts. And with this, it is really questionable whether you still need these big energy supplies. And we see this as a challenge together with our customers to find more intelligent solutions, because in the urban space, I think it's very good that the cabinets are minimized and the impact on the overall street and urban architecture is minimized.
Mm-hmm. Okay, I see. So miniaturization of the traffic controller cabinet in the end is one of the goals of SWARCO X-Line. You brought some components here which can be found in an intersection design. What are the changes with regard to the traffic light pole?
The traffic light pole is now serving as an intelligent communication hub. We have here an electronic, and that is used to actually terminate all the traffic that is going towards the signals, and it's very easy to just put in the cables coming from the earth and from the central cabinet, just put them here, and from here you go further towards the signals. This also serves as a communication hub to integrate other components in the system, like here's some space where you can put some loop detectors. So also the loop detectors are integrated into this system. And you have also some space where you can put other components, traditional components like push buttons. So everything that is on the pole can just be connected to this unit. And then it is only a very thin cable that is required that you go actually back to the central cabinet. The feedback that we receive from the market is that everybody sees this as a major advantage of this solution, that we are able to integrate the complete functionality and really transform the way we build intersections in the future. One thing that people also like is we have this simple plug solution found. In the past, it was required that for each and every cable that comes from the signal heads, you have to connect them to a plinth, each and every cable single. And now it's possible with one signal, you just use the plug, put it in. By this way, you reduce significantly the number of errors it's possible to make. And the whole setup of the system is much more easy and reliable.
Mm-hmm. So wiring is much easier than before. I see a module of a traffic light here also. What does intelligence mean with regard to the LED traffic light?
Let me show you this traffic light. So we have changed it a bit so you can actually take it off and take a look inside. This is the new intelligent functionality for the traffic light. There is advantages to have this intelligence in here. So it is possible not only to drive and supervise the signal, but it's also possible to have functionality integrated that does the supervision of the traffic light with regards to the light time. So the light time of such a traffic signal depends on two factors. One is how long has it been burning, that is affecting the lifetime of the LED. And the second factor is how warm was it. And the temperature is something that you can only measure in the signal itself. The nice and cozy cabinet maybe is not the good place to do it and get a reliable measurement. So we use the same principle of the distributed intelligence to also here reliably determine when is the signal going to fail. And by this way, we make possible preventive maintenance actions. What you can also see here is that the power cable is obviously 4 wires only. So there is the CAN bus and there is the power, which makes it much easier to do the wiring. The signal as such is also possible to implement further and intelligent features for the signal, such as dimming. So you just send the command, go on with only 80% of the luminescence that is usually required. Or some feature that is also important, which is in the old times, you had to configure the signals in such a way that they are brighter than required because the LEDs degrade over the lifetime, so they get darker. In order to make sure that at the end of the lifetime you still have the required level of luminance, it is important that in the beginning it's a bit higher. With the new technology, this is no longer needed. At the very beginning, you can configure the signal that is with the required brightness, and it will keep this brightness over its lifetime because it's supervising itself. So this is also a major advantage that you have from this solution.
Mm-hmm. Fine. Yeah. We talked already a little bit about the wiring. Which positive consequences does SWARCO X-Line have with regard to the wiring plan of an intersection? You brought also some cable here. Hmm?
In the old times, I call this, you had these big chunks of cable, you had 2 wires going to every signal. And in the new times, it's only needed to have a very thin cable. There's wires for power, and there's 2 wires for the serial control, which is the CAN bus. And this is everything that is required in order to come from the cabinet towards the pole. And then it's only required that you can go from pole to pole, actually, and you don't have to have a separate cable going to each and every pole, which means we can save a lot of just cable, hard work, and material that we have to use for copper and tubes.
Yeah. Fine. So wiring is getting much more convenient, is using less material in the end also. I assume there are more advantages of SWARCO X-Line also in terms of environmental friendliness, energy efficiency, civil engineering works, reliability and safety. Can you relate a bit on that?
We have touched on some of these issues already. We have less power that we require to drive the signals. That reduces also the overall power consumption of such a system. So all the other components can be designed in such a way that they rely only on lower power. So the overall system solution goes to lower power. Then we have consequences coming from the reduced cabling. So we use less copper, less primary resources, and less tubes and less digging. In situations where we can actually use the existing cabling, it's also possible to run our communication links about the existing cables. So in a situation where you, for example, want to reinstall blind people signals with an existing intersection, you can just reuse the existing wiring, put in the blind people signals, and use the X-Line to free the cables that you require to do the new installations. So this possibility to actually reuse the cables is also a major advantage that we see for the technology. And last not least, there's also the overall architecture for the system, the urban advantages that we can see from the smaller cabinets.
Yeah, fine. To summarize the story of SWARCO X-Line, in which way is the SWARCO X-Line future-oriented and practical for cities?
The feedback that we have from customers is very, very positive. A lot of our customers, they come, this is the solution that we actually see that attacks a problem that we have, which is the handling of the cables is not bringing us into the future. We need something different there. This is one aspect. And our way to go forward and really integrate all the components that are on an intersection on such an intelligent system is something that the feedback as we receive it is very, very positive. And this is the way forward that we actually want to go. There's also the possibility to integrate further components in the future, like cameras, like communication to vehicles that is required in such a system. And as we have seen for the signals, people are looking for intelligent features in these components. And this applies to other components as well, where you can do remote configuration or such features that are difficult to implement in a system where you only have an electrical connection towards a component. So to have these possibilities is very good in order to pave a way for the future. Also with regards to applications you might consider like autonomous driving, but that is maybe a bit too short time to fill that issue now.
Mm-hmm. Yeah, I can add to this topic that we have SWARCO X-Line right in front of our door here in Buttons, because SWARCO installed an X-Line system here at one of the traffic light controlled intersections in Buttons, and the feedback from the population we get is that the traffic is flowing much better. There is much more fluency in the traffic because there are complicated intersections nearby here. And now with a system where we have some kind of ramp metering in the end, for highways we would call it ramp metering, we have the possibility to make the traffic flowing more smoothly in our town here. Matthias, thank you very much for these clear explanations and for these interesting remarks on modern intersection design. Please stay with us for a few more minutes to answer the questions our audience posted via the chat. Dear followers of our second innovation talk, we are now ready to answer your questions concerning the SWARCO X-Line topic, and we hope that you send us some of your questions and comments via the chat function. As for the time being, I don't see, there is one coming in. Let me have a look. It's coming from India, as I can identify here. Don't you think too much of distributed electronics at the intersections will increase the probability of failure more due to much electronics?
This is a very good question. And our experience so far is that the electronics that we have distributed in our legacy systems that we already have deployed, they are working very reliably. So the environment that we have in the signals, the environment that we have in the poles, we are very able to cope with these. So the electronics is working very good in these environments. Mm-hmm. What we can see also is that the electronics, they are getting smaller and smaller, and the components are getting more and more efficient and more intelligent. So it is not like you have a lot of electronics. I think overall the amount of electronics in such a system is decreasing quite a bit. So overall, my expectation would be that these systems work more reliable than conventional systems, since the effects of miniaturization is having the benefits. Looking back in other industries, I think there have been similar concerns, like in automotive, when the trend was going towards having more intelligence in the controllers and less in the mechanics. And there is a clear trend and a clear direction, and the success is with putting intelligence into the parts.
So in your eyes, the probability of failure is not higher than normal.
It should decrease.
It should decrease even, yes. There is another question. What kind of cable connectors are required?
There are different parts for the cables. The one part is in the cabinets. And in the cabinets, we have these cables that we use on standard. But we can also cope with traditional cables, that is the 32 cores that we have with an existing cabling that we use for earth cables. And the same connector goes into the pole, and the connection in the pole is this part where it's connected to. So these plinths that you just put this in. And towards the signals, we have these plugs that actually are used to very simply connect the signal heads towards the system.
Mm-hmm. Okay. Yeah, dear audience, I can only encourage you to send us more questions. I have one here from Abu Dhabi. Is the X-Line specific to a particular series of products, or can existing installed products be retrofitted with certain additional components to make them achieve X-Line features?
We have, for our traffic controllers, the access controllers, they are able to be retrofitted with X-Line. So if you have space in the racks, you just put in another card that allows you to connect X-Line components. In this way, you can extend an existing installation very easily with X-Line. That might apply, for example, if you have the case that you have a new sub-intersection, say a pedestrian crossing that's just 100 or 200 meters away from the main intersection, and you can use the existing controller to also control this small intersection. So yes, it's possible to extend existing installations with the new technology.
Yeah. There is a question coming in from the United Kingdom. How do the technology costs compare to a standard traffic light controller system?
Currently, what we have for this system, that we see that it has increased value for everybody that is using this. So you have the advantages that you use less energy, that you have only less demanding space requirements, and you also have advantages when it comes to features and when it comes to maintenance. So there we see a better value for everybody who is using that system.
Another question coming in from India. Also, what about working issues on medians dividers where we have the electronics? Closing a lane in Mumbai with a saturated traffic is impossible, so maintenance is difficult. Also in Asia, where there are many accidents, putting down the poles will damage the electronics too. So this is not a question, maybe it's a comment. The situation is different from country to country. Is there a concern about the vulnerability of such a system?
This has been an issue that has been brought up. If you look, for example, at the cabling, since there are less cable, our expectation would be that it is more reliable. So you can, it is not that the new cabling makes the system in any way more vulnerable. So this, I don't foresee that this is going to change. Inside the poles, that might be the case, but on the other hand, sometimes also a cabinet of a traffic controller gets run over, and that occurs less often. But it's then more costly in the conventional system. So I don't know whether this effect is going to even out, and very much depends also on the individual agreements they have.
Yeah. Let's come back to the topic of safety. What kind of safety level do you meet with SWARCO X-Line?
In SWARCO X-Line, we are very happy that we have a very high level of safety for the traffic signals. They are certified to be SIL 3 compliant, and the overall system is also SIL 3 compliant. And safety integrity level 3, as it is called, that is the safety integrity level that we achieve for and is foreseen to be sensible for the traffic, for the road traffic. So like you have higher levels for train traffic and maybe less for individual smaller components, but for the intersections we achieve the SIL 3.
Question from the UK. Does the system support low-level terminations, which means modules in the base of a signal pole for improved maintenance? Does the system support low-level terminations, which means modules in the base of a signal pole for improved maintenance?
What we have obviously is the maintenance work for the overall intersection that is not changing. So there's the tools that usually you have in order to check the safety integrity of the intersection that work still as they have been before. So the tools are unchanged. For the modules that are in the pole, obviously there is this part of this pole unit is dedicated to actually have an overview over the status of the connected signals. So these LEDs can be used to actually quickly glance whether there's anything wrong with configuration or cabling in the pole. So this supports specific maintenance in the poles.
Another question, using CAN bus as opposed to dedicated cables also reduces the resilience of the system, it seems. A cable fault near the controller would result in losing the whole intersection. Is that correct?
If you have a cable fault that goes to a specific critical signal, then you also lose the whole intersection. So since every signal has to be working reliably, I don't see that this is really a change, and we have received quite the opposite, that the line controllers that we built, they are very reliable. So in practice, we do not see this as a concern.
Yeah, losing an intersection is a big word for because you never lose an intersection, because as soon as there is a failure coming up, there is still a safety status in place at the intersection. This is a must, of course.
Sure.
Yeah. Fine. Another question from my side. The LED technology in traffic lights is, of course, almost immune to phantom light effects. At what level of phantom light mitigation are we with SWARCO X-Line?
We are very happy that for the X-Line we have settled the highest phantom class that is currently defined. So we go for the phantom class 5 for all possible combinations of lens and signals. So we reach in all cases the phantom class 5, which gives our customers the highest reliability.
Okay. Yeah, are there more questions coming in? I will wait a short moment. Our innovation talk already takes 30 minutes now. This is the length we promised you not to overstretch, but we are here to answer one more question. And let's wait for a second. There does not seem to come in anything anymore. Well, dear business partners and friends of SWARCO, dear colleagues, thank you for joining our second innovation talk. I cordially thank Matthias Nolle for being with us, for his availability and the clear insights in modern urban traffic control design made by SWARCO. And I also thank those colleagues who are in the background to look after the function, the good function of the whole system of our webinar. Thank you very much, Christoph Praxmara and Benjamin Steiner, for your work behind the scenes. We hope you enjoyed the webinar and got new insights into SWARCO's competencies and capabilities. The questions you might have still, and those we could not answer for time reasons, you can send them to innovationtalks@swarco.com. So that's the email address, innovationtalks@swarco.com. So there you can send your question and we will answer them immediately. Of course, our innovation series talks goes on. Please follow our website and the social media channels of SWARCO to learn about the next topic and the next date, which will most probably be in August. We look forward to welcoming you then again. In the meantime, all the best, stay safe, and goodbye.
Bye-bye.